Hi guys, this is lesson 5-5 in your textbook, and it's titled How to Use Inequalities in a Triangle. Okay, so what I've done right here is I've drawn two different triangles, and as you can see in the first one I highlighted the longest side in red and also highlighted the largest angle in that triangle. And as you can see, they are opposite one another, the longest side and the largest angle. Well, the same goes for the shortest side of any triangle and the smallest angle. They're going to be opposite one another. So this fact is going to remain true for all triangles. And this is bringing us to our first theorem for today. Theorem 5.10 says, let me just move this up. If one side of a triangle is longer than another side, then the opposite angle from the longer is larger than the angle opposite the shorter side. Okay, so in this example, I've drawn a triangle ABC, and I've shown that AB is 8 and BC, the length of that is 5. So already we know that AB is bigger than BC. So if AB is greater than BC in measurement, then the angle opposite, which is C, is going to be bigger than the angle opposite BC, which is angle A. So then the measure of angle C is going to be bigger or greater than the measure of angle A. Okay, awesome. And there's a second theorem that is very, very similar. It's theorem 5.11, and it says if one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. So this time we're given two angles, and if we know that one angle is bigger than the other, then we know that the side opposite the larger angle is going to be longer than the side opposite the smaller one. So in this case, we are told that the measure of angle A is greater than the measure of angle C, and so if that's the case, then BC, in this case, is going to be bigger than AB. Okay, so let's go ahead and do an example based on this. We're given a word problem, and we're told that 3 wooden beams will be nailed together to form a triangle. I'm not sure what it's for, but that's our scenario. And the bottom beam is 8 feet, and the sides are 12 feet and 14 feet. One of the angles inside the triangle is 86 degrees, and another is 35 degrees. So in the end, we're asked, what is the angle measure opposite the largest beam? So we're not given any pictures. And what helps me in any word problem is drawing a picture. So I'm just going to go ahead and just kind of sketch a picture. It's not going to be accurate, okay? I just kind of need a visual to help me out. So I have a base that is 8 feet. And then I have two sides. One of them is longer than the other. So one of them is 12 feet. And then the other one is 14 feet. So I'm just going to make sure that one just looks slightly longer in my diagram. And then I'm going to label them 12 feet, 14 feet. Okay. So this is what I'm given. I'm also told that one of these angles inside is 86 degrees and another is 35 degrees. I don't know what the third angle is, though, that must be necessary to complete this triangle. But I do know that they all add up to 180 degrees. So if I have 86 degrees plus 35 degrees plus some missing angle, I'm going to be able to find that that missing angle is 59 degrees. So, out of my 3 angles, 86, 35, and 59, the largest one, which is 86, should be opposite the longest side, which is 14. So in my diagram, this would have been the 86 degrees. Okay, and that's what we're asked. What is the angle measure opposite the largest beam? It is 86 degrees, and that's my answer. Just for fun, if you wanted to fill in those other 2 angles, the next biggest one would be across the next longest side. So this one would be 59 degrees, and then this top angle would be the 35 degrees. Okay. So moving on, there are different rules for the sides of triangles. Okay. I've drawn a triangle right here, and let me cover this up as well. You don't need to read that yet. So I've drawn a triangle, and I've labeled the sides. I measured them. This was 4, and this was 3, and this was 2. Okay, so would I be able to draw a triangle with any measurements that I'm given? So how about I just keep the 3 and the 2, but I make the bottom of the triangle even a little bit bigger. I'm going to make it maybe 6. So if I was going to try to draw this, it's actually not going to work, okay? Because the 3 and the 2, they're not long enough to actually meet. There's going to be a gap in this triangle. So we need to come up with some rules for the sides of any triangle. And this brings us to our last theorem, Theorem 5.12. It's called the Triangle Inequality Theorem. And what it says is that the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So writing this out, if I was going to add length AB plus BC, it must be greater than the third side, which is AC. Okay, but this also goes if I was going to add BC plus AC, it must be greater than the third side, which in this case would be AB. And also if I wanted to add AB plus AC, it must be greater than BC. So these are kind of the three rules that we can get from this diagram based on this theorem. So we're going to close with one example that's very, very similar to this. Okay. It says a triangle has one side length of 11 and another of length 6. And we're asked to describe the possible lengths of the third side. Okay, and it might be kind of weird that I drew two different triangles, but if I'm just given two different sides and not the third, there's so many different options for what that third side could be. It could be that the third side is smaller, okay, than the other two. And so that's kind of the triangle that I tried to draw to represent that. So what could this third side be? Well, based on what we just learned, if I added x plus 6, we know that it must be greater than that biggest side, which is 11 in this case. Okay, and so x would be greater than 5. So that means I could pick 6 again, I could pick 7, I could pick 8, 9, okay, all of those would work. But for instance, if I picked 5 or if I picked 4, it actually would not reach as far as the other two sides were that I was given. Similarly, in this other one, maybe the 11 and the 6, maybe those were the shortest sides, and I had another side that was actually longer. So this is the missing side. So what I would do is kind of the same thing. I know that 11 plus 6 must be greater than that third side. 11 plus 6 is 17, which means that 17 must be greater than x. So because I'm given two different inequalities, I must put those together in the end to find out what's the range for the x's that I'm given. So what I'm going to do is I'm going to keep this one, but I'm going to flip it so that it says 5 is greater than x. I'm sorry, I totally messed that up. 5 is less than x. And I'm going to flip this one as well so that it says x is less than 17. And now I can combine both of those and say that 5 is in the range where 5 is less than x, but it's also x is less than 17. And this would be my final answer. This is our compound inequality. Okay, so I can pick the numbers 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16, and they would all work for a missing side length, or anything in between. I could do 6.5 even. Okay, so on your own, I just want you to try a problem very similar to this. This triangle has a side of 14 inches and another side of 18 inches. What are the possible lengths of the third side? And when you write your final answer, I want you to write it just like this, as a compound inequality with x in the middle and the lowest value all the way to the highest value on the right. Okay, I'll see you when you come back to class.